Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I'm going to answer one question that appeared on the SQL BI website as one of the many questions that appear to our articles. The question was how to compute a running total that resets at points in time that are defined in data. Now, a running total is nothing but a number that always grows, accumulating values from the beginning of time. So, sales amount for the first day, then the sum of the first 2 days, 3 days, 4 days, and so on over time. A running total might be reset. For example, if you compute a year to date, that is a running total that resets on the 1st of January. So it grows during the year, and then on the 1st of January of the next year, it resets and restarts computing values. The requirement here is slightly different. The running total needs to reset, but the date when the reset happens is not one day in the year, one known day in the year. It depends on data. We have a table that tells us when to reset, and you might have multiple resets during a year or no resets at all. The reason why I think this example is interesting is because you have no predefined function, of course, that computes this value. Therefore, it is very simple to answer, to write this code and to answer the problem if you know DAX and if you learned it the right way. Whenever I teach time intelligence calculations, I always show the year-to-date calculation. But I do not just show dates YTD or total YTD, the predefined functions in DAX. I always teach first the hard way, so how to compute a year-to-date without any time intelligence calculation. And I see in the face of my students that this looks like a waste of time while learning the hard path if we do have a predefined function. And the reason is specifically this. Sometimes the requirements are different and you need to compute a calculation for which you do not have a predefined function. If that is the case and you learned the hard path, so how to compute time intelligence calculation without the predefined functions, then this code is utterly simple to author. So the reason why I like this topic is because it's interesting to write DAX, and it also shows that, well, the way that I use to teach students how to learn DAX is actually a good way, because they learned first the hard way, and then how to have a simpler life by using predefined functions. Well, no more words, let's jump to Contoso. Well, to the article first, we read the question, and then we write the DAX code together, as we always do. Let's get started. First, the reference to the article. The question appeared on this article of, well, more than a year ago, written by Marco. The article speaks about how to hide future dates for calculations in DAX, and the question has nothing to do with the topic actually. So it's pointless to read the article. We can jump straight to the question. Here it is. We can also increase the font a bit. Okay, so it's readable. So hi guys, I have a requirement to show a cumulative total that resets when a certain condition is met. The condition is the generate dimension on my fact table that has a yes or no value. So we have some data in the fact table that tells us when to reset when to do that reset. For example, if we have 10 for every month. For the first month, we have a no for the reset, so we cumulate values 1, 20, 30, and 40. But then for the next 2 months, it resets, so it starts again with 10 and 20. So we need to author this code. And since I do not have the reset table, I do not have this information, we will need to author some code together in order to simulate the problem. Let me jump to Contoso, and this is the starting point. We have date, sales amount. That is our regular Contoso with 10,000 orders, with sales starting in May, 18th of May. First, how do we compute a running total? Well, a running total is kind of simple to compute. We need to remove the filter from the date and replace it with a new filter that contains all the dates that happen to be before the current date. So let's start to warm up ourselves by writing the running total. We can start with a new measure with a bit larger font. Let's call it sales running total. So we need the reference data, and we take the max of date data. Then we define the dates to use. That has a filter of all date data, where date data is less or equal than the reference date. So reference date is the last date. Dates to use contains all the dates before the current date. And then we can compute the result, which is, well, I don't need that, calculate sales amount, and we use dates to use as a new filter, and then return result. This computes a running total with no reset anywhere. Or at least it should compute a running total. Let's check that. We format it, place it in the report, and you see that it shows for the first day the same value, then the sum of the first two, first three, no increase because there are no sales, and so on. So this is a number that always grows without ever resetting. As I said, that was just for warming up. Now we need to add the reset condition. We do not have a reset table here, so I'm going to create a measure that returns yes or no, or true or false, with a completely dummy condition. So we reset every n days, where n can be any number. So let me create a measure for the reset. Let's call it reset. And to do that, let's say that we want to reset every 112 days or 115 days. We can take the date as a number. We take the modulus of that day with any number, and if that is equal to 0, we return true. So we can use a variable date as int, which is trunk of date. No, that's a measure, so we first need the reference data, which is the maximum of date data. Then we convert it to an integer by taking the ref data. So now data's is an integer. And then the result, we just take the mod. Let's say if mod of data's int, let's use 115, equals 0, then the result is true. Return result. So reset contains true or false, and it will contain true every 115 days. This can be any number. I'm not interested at all in the condition. We can place the measure here. We can also get rid of the running total right now. So we will have true somewhere. How do I find where it's true? Well, we can just sort it. The sending, okay. So you see that that measure reset returns true on the 14th of February 2017, and then on the 2nd of October, on the 20th of May, and so on. So we have several days where reset is true, and most of the dates, of course, that is false. What I want to do is my running total to reset on these specific dates. Let's sort again by date. How do I do that? Well, what we need to do is compute something like the running total, so it will be very close to the running total calculation. But instead of always starting from the first of the first date, we need to have a variable that contains the starting point. So the endpoint will always be the last date, the date that we are seeing in the report, or the last date in the current filter context. The starting point is the last date for which we had a reset. So we can search for the maximum date in the date table where reset is true and the date is less than the current date, less or equal than the current date. And that is our starting point. The endpoint is the current date. The period in between these dates is what I need to accumulate for my resetting running total. Let's do that. So, we need a map. Well, we have the reset, true or false. We need to compute first the last reset. So given a date, let's say that we are here on the 14th of July 2017. What is the starting point? So the last date where there was a reset. And we can build a measure for that. Let's call it last reset. Again, we need the reference date, which is the maximum of date. Then we need to find the maximum date in the date table for which there was a reset. This date might be before, anytime before the current selection. So let's create a variable dates before now, which contains a filter of all date where date is less or equal the reference date. These are all the dates before the reference date. Then we need the resets, which filters dates before now, where reset is true. So now resets, let's call it dates with reset, contains all the dates before now that are actually a reset. Out of this set, I need to find the maximum one. So we can create the last reset, which is the max x over dates with reset. The maximum based on the date. Return last reset. If I did it correctly, this should return the last date with the reset for any date. Let's check that. Let's use a format string that is a bit more readable, like this one. And then we drop the measure in the report. So this is saying that the last reset was on the 9th of the previous month. Let's check that. Where are you? On the 9th, of course, we have reset of true. You see we have a value that starts to repeat until there is the next reset that will happen 115 days later. We do have a problem at the beginning because at the beginning, before the first reset, we do not have any value for the reset. So we can fix that. If there are no resets before the current date, then we use the first date ever. So we need another variable, first date ever, which is calculate mean of date, remove filters without any filter. So that is the first date ever. And then we can compute the result, which is a coalesce of last reset. And if last reset is blank, then we use first date ever. First date again. First date ever. Okay, and then we return the result. That should return a value even at the beginning. Let's check that. Yes, you see that at the beginning the last reset is the 1st of January, and then as soon as we do have a reset here, we start returning the correct dates. Now we do have the first date, we have the last date, that is the reference date. If we create a filter that contains all the dates in between the last reset and the current date, we apply that, and that should be our resetting running total. So let's go for the next step, which is our resetting running total. Let's call it resetting running total. We need again the reference date, which is the maximum of date. We need the last reset. We do have a measure now, last reset, which I can just call that. Then dates to use. We can use dates between here. Date. If I don't remember, but we used the filter in the previous calculation for the running total. We could have used dates between the very same way. So dates between date, starting from the last reset and ending with the reference date. Now this table contains all the dates in between the last reset and the reference date. We can go straight for the result, which is calculate sales amount, dates to use. Return result. And that should be it. We format it as a decimal. We place it here. And it doesn't show anything at the beginning because we do not have sales. It starts with the same value as the running total. We can also place the running total here. So that gives us a better picture of what is happening. What happened here? Okay, here we go. We do have the resetting running total and the running total. They show the same value, and they should be identical until we have the first reset here. On this date, we have the first reset. You see that the resetting running total shows the value of the sales amount, whereas the running total goes on growing. And then this will happen again at some point. I expect this number to be smaller. Here again. It went up to 1 million, and then we have another reset, and the resetting running total starts again to count because this is a date where we do have the reset. Let's look at the code for one last time. You see that it's not complex. It does not use, of course, any of the predefined DAX functions. Now we could end it here, but the thing is, so far we implemented the logic. So we created different measures which are mainly useful for debugging because I want to see true false, I want to see the last date as a reset, but you might have noticed that I had to write multiple times pieces of code in different measures. So my feeling is that splitting this calculation into multiple measures just slows down the entire calculation because we are performing the same calculation multiple times. Therefore, it might be useful to author everything as a single measure. But before doing that, it's worth first of all check the performance. Maybe it's already so fast right now that it's not worth doing. If we have the feeling that it's slow, then we can try to make it a bit faster. So let's do that again. The measure is resetting running total. We need to play with performance. That requires us DAX Studio. So let me open DAX Studio. That is here. And we need a reference query. So let's write evaluate. Summarize columns by date. And we use our resetting running total. Server timings, and let's run it. Okay, well, the result, we do have results which are the same we had in the report before, but I'm not interested in the results, I'm interested in the timings. It's quite bad because you see everything is in Formula Engine, which is kind of expected for such a calculation. There's not much that can be done by storage engine. And it takes a bit more than half a second to run. We have a few queries. Let's quickly look at them. That retrieves the date, then again the date, then for each date the maximum date. Then the date and the maximum date. And here we have the set of conditions. And again the set of conditions. So it's pretty clear that Formula Engine is computing the set of dates for that needs to be used, and the entire calculation happens in storage engine. Formula Engine actually does really a tiny amount of work. Most of it is happening in Formula Engine. That again is a good indication that if we can simplify the code, we could obtain better performance. So now that we do have a clear picture of the algorithm, we can get rid of all the measures and write a single measure that computes the resetting running total without relying on other measures. So we reduce to a minimum the number of calculations that we can perform. And we can also use a slightly different algorithm. So we first compute the dates with a reset in a variable, and then we use this variable through the entire calculation. So the hope is that the variable will be computed only once for the entire report, and that should speed up the calculation. But this is more a hope than a certainty, so we need to test that. Let's do that. I need more real estate. So let's define a measure, sales RT1, where we basically do the same operations that we did earlier. We compute the reference date, which is the maximum of date. Then I want to first create a variable that contains all the dates that are a reset. So I create a variable all reset dates, where I filter all date, where reset is true. You see that I no longer have in this variable the condition that the date needs to be less before the reference date, because I want this variable not to depend from the specific cell that I'm computing. The hope is that this variable will be computed only once, and then we apply the condition later. Then we compute the last reset as the max x over all reset dates. No, we need to apply a filter first. var reset dates before now, which filters filter all reset dates where date, that is in the reset date, is less or equal the reference date. Let's get rid of this so we have a bit more space. And now the last reset is the maximum of reset dates before now ordered by date. Then dates to use. We can use dates between date between the last reset and the reference date. And finally, for the result, that is calculate sales amount using dates to use as the filter. Return result. Let's see if the code is formatted correctly. It is, so at least syntactically it should be fine. And instead of returning RT1, let's return RT. And we first look at the result. It doesn't work because it's RT1. Okay, we have some numbers. I'm not sure that these numbers are correct. So it might be useful to add the resetting running total measure in the same query, just to check that these numbers are actually the same. And it looks like. So the new version of the code is still working. It was around 700 milliseconds before. Let's run it now. And it's way better, 27 milliseconds. Because we basically reduced the number of calculations that needs to be performed by the formula engine. So this is a way better piece of code to compute the resetting running total. By the way, it's written in a nice way because you see that at the end it's just a calculator of sales amount with a filter over the dates. So by replacing sales amount with selected measure, you can transform this into a calculation group that works on any measure. Actually, we can't do that. I mean, we can just take this code, which works fine, go back to Power BI Desktop, we use Tabular Editor, where are you opening Tabular Editor? Here, but I want to here. Okay, we can create a calculation group that we call let's call it running totals. We created two calculation items. One is no calc that only returns the selected measure. And then we create a new calculation item that we call resetting RT. I just paste the code that we wrote earlier. Let's format it. It's the same code, and here instead of sales amount, we just use selected measure. And that is it. We can save this, go back to Power BI Desktop, refresh. Now we can leave sales amount here. Let's get rid of all these columns. We only have our sales amount measure. And I should have here somewhere my running totals. Well, I just use name, which is not really cool, but that is not a problem. You see that with no calc, it provides the same value as the sales amount. With resetting running total, it shows the resetting running total that resets at given points in time. And that is going to work for the sales amount, for the margin. We can actually filter. I called it name, which again was not very smart. You can use only resetting running total. So we have the sales amount, the margin, and both are reset. Also the margin percentage. Show a growing margin percentage that resets at some given point in time. So, time to draw some conclusion at this point. As you have seen, we wrote different versions of the code. The important point is that first we needed to do debugging. We needed to think about the measure. That led us to write different calculations, one for the reset, one for debugging purposes, one to compute the last reset, and finally the calculation as a measure. Which was fine, but writing so many measures for such a simple calculation is not your best option. Once the algorithm is working and you are confident that you understood exactly the logic that you have implemented, then is the time to worry about performance and try to simplify, not to simplify, but to write the entire calculation, trying to reduce the number of repeated calculations. And that led us to a good improvement in terms of performance. 27 milliseconds is a very good number and it's not worth going further. Again, I know I'm stressing it, but I think it's important. This code would be easy if you learn DAX the right way. Learning DAX the right way means you need to understand that we do have predefined functions that are used to simplify authoring DAX code, but you can actually compute any time intelligence calculation without ever relying on predefined functions. And even though this looks like a useless exercise, it is actually extremely important, because making practice in writing your own time intelligence calculation without using the predefined functions shapes your brain in such a way that the next time you will face a similar challenge, you will just solve it in a simple way because you learned how to use DAX in the best way. I hope you enjoyed the video, and as I always say, enjoy DAX.